there is another modulation technique, that is the frequency modulation. In this case, what we do is we change the frequency of our signal, of our carrier signal, in accordance to our message signal that we want to send. Okay. So FM modulation is all about that. Now in this case also we use a particular audio oscillator in order to generate first of all the message signal. Okay. And then that audio oscillator provides, input is given to a reactance modulator or any other modulator which is an FM modulator. There are various types of FM modulator. Vector modulator is one, reactance modulator is another, and there are various ICs which also do the FM modulation process. Okay. So you can use any of those modulators in order to generate the FM signal. Okay. The same thing as in the previous case, there was a carrier which was getting modulated in accordance to our amplitude. Amplitude was getting modulated in accordance to our message signal. The same thing happens here, but this time the amplitude does not change, but the frequency of the carrier signal changes. Okay. Now the frequency of the carrier signal changes in accordance to our message signal. Okay. So for example, in this experiment, what you have to do first, you have to observe the FM modulation. Okay, FM modulation process. You have to first observe your audio signal, note its frequency as well as its amplitude. Okay, this is the audio signal that I am giving, message signal or the modulating signal. Okay. So after that, you will utilize a reactance modulator in order to generate the FM. Now there is a toggle button here in order to select which type of modulator you want to use. Okay, there are 2-3 modulators here on this case. You can use any of them for generating your FM signal. Okay. So if for example I use the reactance modulator, then I will connect my probe at the end in order to notice the FM. Okay. Now here the carrier is provided carrier signal which is generated inside the carrier signal itself generated inside the reactance modulator. There is no separate box for that generating the carrier signal as it was in the transmitter. There was an crystal oscillator for generating the carrier. Here it is inside. Okay. There is an oscillator inside this reactance modulator which generates the carrier at around 455 kilohertz. Okay. After that, you will observe your reactance modulated output of the reactance modulator. You observe a signal like this. So as you notice, whenever the amplitude of the modulated signal is changing, at the corresponding points there are also compressions and rearfractions. Okay. So this shows that whatever signal that we are giving, message signal that you are giving, its information gets stored in the compressions and the rearfractions of the carrier signal. You know? So this signal represents the FM frequency modulated signal. Okay. So this you have to first of all observe here. Okay. And you have to take the photograph of the same. After that, we utilize in this FM modulator. Now, in this FM modulator, we don't change the amplitude of the carrier signal. Okay, in accordance to our message, we change the frequency of the carrier signal at a particular point. You will also change your amplitude of the message signal. You will notice the very similar variations will occur in the compressions and the rearfractions of the FM signal that we are producing. For example, I am changing the amplitude. As soon as I am decreasing the amplitude, the more the carrier signal will be less affected. Okay, less the carrier signal will be affected. As I increase the amplitude, the more the carrier signal will be affected by my message signal. Okay, and correspondingly, if I change the frequency in the similar manner, the FM signal will also change. Okay. We'll observe the same things. After doing this, what we do in FM, there is an as we do not need anything, we do not provide any data in the amplitude of the carrier signal. So sometimes what happens that noise or interference comes inside the modulator. Okay, so we use an amplitude limiter circuit in order to limit the amplitude, okay, of the FM signal that we are generating, so that any noise or interference that occurs which varies the amplitude of the carrier does not affect our received signal. Okay, does not affect our detected signal, because we are not storing our message in the amplitude now. We are storing it in the frequency component, okay, of the carrier signal. So this time the amplitude of the carrier signal can be anything. It doesn't matter. Okay. After this, you will detect the same signal. Now there are various types of FM detectors also. There was a super heterodyne receiver that we are using for detecting the received signal for AM modulation. Now here also there are various types of detectors. I told you about there is also a tuned radio frequency receiver for AM detection. You know? I have told you about that also. Similarly, there are various types of detectors here also. There is a quadrature detector. There is a detuned resonant circuit detector. There is a Foster Siley detector. There is a phase lock detector. No, and after those detectors circuits, there is obviously a low pass filter. Okay, which emits out the higher frequency components. Okay, after that you will observe the received signal or the received message signal that we are providing, the modulating signal that we are providing to you, our FM. Okay, that we are using for FM transmission. Okay, so what you will do finally, you will select any of the, there is a toggle button for selecting any of the detector circuits. You will select any of the detector circuits. For example, I will first of all select the quadrature detector. Okay, and I will observe the received signal. Okay, so now what I have done, this is my modulating signal or the message signal that I have given, and this is the received signal that I have obtained. Okay, now you will know measure the amplitude of the received signal and the frequency of the received signal, and notice that the frequency of the received signal must be equal to the given frequency. Okay, the given message signal frequency, like you are doing in the AM reception experiment. No? So you will do the same thing. Now what you will do, you will change your detector to another detector. Okay, and notice the change in the amplitude of the frequency. You will see what you will do by this process. What we expect you to do is to you find out which of the detectors works the best among the following. There is quadrature detector, there is detuned resonant circuit detector, there is Foster Siley detector. Okay, you have to verify which of these is the best for your signals. Okay, maybe you can also change the frequency and the amplitude and notice the corresponding change in the detected signal corresponding to each of the detectors. Okay, after this doing this transmission and the reception of the AM signal, okay, then you will move towards the beta calculation. That's the modulation index calculation for the AM signal. Okay, now for that purpose what you have to do, you have to use frequency based IC based frequency modulator, which is at the end. Now how can it be selected? Using this toggle button. Okay, so what you will do, you will finally select this reactance based modulator. Now why we are using this for beta calculation is because here we can vary the carrier frequency from 10 hertz to 200 kilohertz. Okay, so the FM modulation, that is the frequency change, that is the compression and the reflections in the FM signal, are more visible when we utilize this modulator. Okay, so it will be very easy to calculate beta from this modulator. From those modulator, as the frequencies, carrier frequencies around 455 kilohertz. Okay, and we can only vary the FM only vary the frequency of those carriers in accordance to our FM signal, a message signal, by 2 or 3 kilohertz in all those modulators. So you will not be able to easily measure the compression and the rear fractions. Okay, so in order to calculate the beta, we have used this frequency modulator circuit. Okay, so what you will do in the frequency modulator, how you will calculate the beta value. First of all, you can also notice, you can also first of all find out the only the what is the carrier frequency at this particular point given to the frequency modulator by cancelling out the amplitude of the signal that is not providing any signal. Okay, now at this time I'm not providing any signal to the frequency modulator. Okay, so this is unmodulated carrier here. So you will notice its frequency and amplitude. Okay, you can also change its frequency by this. Okay, now here this option is available. This option was not available in these other setups. It was available, but you could only change a very little bit. Okay, you could only change by only 3 kilohertz. Here you can change by a lot. Okay, that's why you can observe. Finally, after doing this, I will increase, as soon as I increase the amplitude of my message signal, you will notice the same will be happening in the FM signal. Okay, same changes will be reflected in the FM signal. Okay, correspondingly the changes will be reflected in the FM signal. Okay, actually what as soon as I increase the amplitude, the capacitance of the modulator, this modulator changes, frequency modulator changes. Okay, at that particular point, at this point for example the amplitude is low, you know, so capacitance will be decrease it, so frequency will increase. Okay, so there will be a compression here. At this point amplitude will be high, capacitance increases, the frequency decreases, है ना? Okay, so finally here there will be refractions, or the cycles of the FM signal will be away apart from each other. Okay, so what you will do in order to calculate the beta, what you have to do, there's a how much this amplitude, this frequency changes. This frequency changes in accordance to our message signal, the amplitude of our message signal. Okay, now so what is happening is that we are storing the data of our message signal in the frequency of this carrier. This process is known as the FM. Okay. Now what we will do in order to calculate the beta? Beta for modulation index for the FM signal is given by Kf AM by FM. Okay. Kf is the frequency sensitivity. Okay. In hertz per volt. Then there is AM. AM is the amplitude of the message signal. Okay. And FM is the frequency of the message signal that we are giving. So when deviation in the frequency, that is when there was no amplitude, there was a particular carrier frequency, not the deviation in the frequency that is occurring because of our message signal that we are providing is represented as del f. Okay, del f is itself equal to kf am. Okay, now if मैं बताऊंगा, I will tell you that.
ऑब्जेक्टिव है ना, लास्ट
I will tell you that.
आपको केएफ डिटरमिन
मैं बताऊंगा ना आपको.
पहले बीटा फिर केएफ.
मैं आपको बताऊंगा. देखो. Now del f is the change in the frequency that is occurring because of our message signal, है ना? So how we will notice the change in the frequency? What you will do? You will maybe ये खत्म ही कर देते हैं. Input message signal खत्म कर देते हैं for particular time, ठीक है ना? इसको ला देते हैं center में. Bring it to the center. Increase a little bit of your time period. Okay. Just stabilize this waveform or maybe stop it here. Okay. Notice the time period here of the compression. So here's the compression, na? Now notice the time period here in the compressions or in the rear fractions. How we will do that calculation of the time period? You will use a cursor, select the channel which you are utilizing, channel 1. Okay, and now change it to the time. Now utilize the cursor and notice the time period here in the rear fraction part first of all, or in the compression part, any of the. Okay, now in order to notice the time period, you have to select one of the cursor at a particular point and the another at the end of that cycle. For example here, okay na, pura end cycle message signal in the rear fraction part. So you will notice the time period. Okay, what is the time period difference between the two? So difference between the two is around del is around 96 microseconds. So if you consider it around 100 microseconds, almost it's approximately equal to 100 microseconds, which is equal to 0.1 milliseconds, which is equal to 10 kilohertz. So del f is here 10 kilohertz. That is the change in the frequency that is occurring because of our message signal. That from the change that is occurring in the frequency of the carrier signal because of our message signal is kitna 10 kilohertz. So del f you have calculated now 10 kilohertz. Now del f divided by the message signal frequency that you are giving, del f by fm, okay, is equal to your modulation index or beta. Okay, beta is equal to del f. वहाँ पे लिखा है ना, देखो, del f by fm. Now del f is itself equal to kf am. Okay, now you also know the amplitude, okay, and the frequency of the message signal. Now kf is also known, am is also known, fm is also known. So you will and beta you have calculated already by del f by fm formula. Okay, now you will calculate the frequency sensitivity kf value. Okay, did you understand?
बट ये तो रेयर फ्रैक्शन का है ना.
हाँ
ये
देखो,
आप सिंगल टोन यूज कर रहे हो ना.
देखो बेटा, देखो
हाँ सिंगल टोन यूज कर रहे
देखो बेटा, जब अगर हम कंप्रेशन है ना, कंप्रेशन में भी होगी ना फ्रीक्वेंसी चेंज, क्योंकि वहाँ पे हमारी मैसेज सिग्नल का एम्पलीट्यूड कम था, इसलिए होगी ना वहाँ पे भी, तो उस तरफ भी डेल एफ हो रही होगी फ्रीक्वेंसी चेंज, इस तरफ भी डेल एफ हो रही होगी. अगर आप कंप्रेशन का भी कैलकुलेट करोगे ना, तो क्या हो जाएगा, तो आप 2 टाइम्स डेल्फ कैलकुलेशन पे पहुंच जाओगे, ठीक है ना। यू विल बी एबल टू कैलकुलेट। अगर आप कंप्रेशन का भी एम्पलीट्यूड
एम्पलीट्यूड तो सेम ही है।
एम्पलीट्यूड नहीं, मैं कह रहा हूँ टाइम पीरियड अगर कंप्रेशन के टाइम पे भी मेजर करोगे ना और उसका उल्टा लोगे फ्रीक्वेंसी लोगे, ठीक है ना, तो वहाँ पे आ जाएगा जो आपकी चेंज आ जाएगी ना, दैट वो जो डेल एफ आ जाएगा ना उस केस में वो भी होगा इस डेल एफ के बराबर। वो अब नेगेटिव साइड से होगा या पॉजिटिव साइड से होगा,
आपका
ओके।
मिनिमम फ्रीक्वेंसी जो निकलेगा ना रेयर फ्रैक्शन में,
क्योंकि हम
माइनस योर
सिंगल टोन
अनमॉड्यूलेटेड कैरियर
क्योंकि
विल
हम
गिव यू
सिंगल
डेल्टा
टोन साइनोसाइडल सिग्नल दे रहे हैं, तो साइनोसाइडल
Symmetrical
सिग्नल
है।
पीक टू पीक सिमेट्रिकल है, वो पीक टू पीक वेरी कर रहा है, एक साइड से पॉजिटिव एंड है दूसरे साइड से नेगेटिव एंड है, ठीक
जितना
है
वो हाई ले रहा है
जितना
उतना वो लो भी
जितना वो हाई जाएगा उतना वो लो भी जाएगा, है ना। तो रियर फ्रैक्शन में एक साइड से चली जाएगी डेल एफ वैल्यू, दूसरी साइड से इसमें। फॉर एग्जांपल अगर कैरियर की फ्रीक्वेंसी अभी 10 किलो हर्ट्ज है ना, तो रियर फ्रैक्शन के टाइम पे जो फ्रीक्वेंसी आएगी ना हमारी वो आएगी अराउंड 15 किलो हर्ट्ज, सॉरी कम आ जाएगी 5 किलो हर्ट्ज, और कंप्रेशन के टाइम पे 15 किलो हर्ट्ज। तो डेल एफ दोनों साइड से चेंज हो रहा है, ठीक है ना। तो आप कहीं से भी निकाल सकते हैं, यू कैन ऑल्सो कैलकुलेट। अब रियर फ्रैक्शन में इजी हो जाएगा कैलकुलेशन, क्योंकि कर्सर एस्टैब्लिश करना इजी हो जाएगा, उसमें थोड़ा साइकिल्स नजदीक हो जाएंगे तो डिफरेंट हो जाएगा।
दोनों सेम होगी।
हाँ
नहीं दिस यू
दोनों
से ये जो सर बता रहे थे ना ये करो कैलकुलेट। फॉर एग्जांपल रेयर फ्रैक्शन में आप कर रहे हो मिनिमम फ्रीक्वेंसी मतलब वाइडेस्ट साइकिल पे आप कह रहे हो, तो दैट विल बी योर एफ मिन, राइट। Then you have your unmodulated carrier frequency when you had set the amplitude to 0 that you had noticed earlier also, fine. So you can subtract the two, you can get del F. अगर आप even अब compression में भी जाते हैं तो compression will be about that nominal FC value, FC plus that del F will be same जितना अगर आप symmetrical wave use कर रहे हैं।
देखो क्या होता है, I will show you। देखो कैरियर फ्रीक्वेंसी, फॉर एग्जांपल कैरियर फ्रीक्वेंसी इज एफसी, नो एफसी प्लस के एफ ए एम, ठीक है ना, वो देगा आपका मैक्सिमम फ्रीक्वेंसी यानी कंप्रेशन की फ्रीक्वेंसी, ठीक है ना। एफसी माइनस के एफ ए एम, ठीक है ना, वो देगा आपका मिनिमम फ्रीक्वेंसी, ठीक है ना। तो अगर हमें कैलकुलेट करना है के एफ ए एम यानी डेल एफ कैलकुलेट करना है, ठीक है ना, तो अगर हम एफ मैक्सिमम माइनस एफ मिनिमम करेंगे तो क्या आ जाएगा, एफ सी प्लस के एफ ए एम माइनस एफ सी माइनस के एफ ए एम, तो 2 टाइम्स के एफ ए एम आ जाएगा ना, तो 2 टाइम्स डेल एफ आ गया ना। वही मैं कह रहा हूँ, आप वो वैसे भी कर सकते हो ऐसे भी कर सकते हो, आप वहाँ से भी कर सकते हो यहाँ से भी कर सकते हो, या दोनों को पहले इधर कर लो फ्रीक्वेंसी कैलकुलेट, फिर इधर कर लो कैलकुलेट, फिर माइनस कर लो, 2 टाइम्स आ जाएगा, ठीक है। इससे कोई फर्क नहीं पड़ेगा, इजी हो जाएगा आपको इफ़ यू मेजर इट हियर, क्योंकि इधर पे साइकिल्स विजिबल होंगे ना ज़्यादा रियर फ्रैक्शन में। तो आपका डेल एफ जब कैलकुलेट हो जाएगा फिर बीटा भी कैलकुलेट हो जाएगा, बीटा कैलकुलेट हो गया तो फ्रीक्वेंसी सेंसिटिविटी भी कैलकुलेट हो जाएगा। तो जब बीटा का वैल्यू है ना, अब एफएम में क्या होता है, जब बीटा का वैल्यू बीटा वैल्यू इज लेस देन 1, it is known as a narrow band FM. Okay, the narrow band FM is similar to the AM signal. Okay, there is only what is the difference is that the lower sideband, there is a phase shift of there is an inversion of phase in the lower sideband. Okay, only that's the
because there is
difference.
plus minus
That's-
वाला
और
sign.
एक डिफरेंस है वहाँ आपका था AC MAC by 2
हाँ,
MAC,
यहाँ
यहाँ है
पे
J0 बीटा
हाँ।
J1
There's a
बीटा
best- मैं वो बेसल फंक्शन है ना, फिर वो समझाना लेकिन में जाएंगे
नहीं
ना।
उन्हें क्या होगा ना कैनेडी में कर लेंगे ना बेसल फंक्शन
हाँ दे हैव टू डू फॉर
है ना
बैंड।
वो पढ़ाया?
का बहुत जरूरी
इन्होंने सिर्फ नैरो बैंड
हाँ
मैं आर्मस्ट्रांग मेथड यूज
जी
किया होगा
नहीं मैंने अभी इंट्रोडक्शन नैरो बैंड नैरो बैंड
न्यूमेरिकल्स को
We
सारे
have-
टेबल
वो
पे
तो
ही
अभी-
लिखा है।
बेसल हाँ बेसल
उनको जानना
इज
पड़ेगा
देयर
आगे।
क्योंकि को स्पेक्ट्रम पढ़ना है।
मैम वो तो समझाना पड़ेगा।
नहीं नहीं मतलब आप
तो यहाँ
बीटा
पे-
लेस देन 1
हाँ just take it consideration narrow band FM is beta less than 1. For beta greater than 1, the FM when the beta value is greater than 1 for a particular FM signal, that is known as a wide band FM. Okay, you will notice that in narrow band FM you will only obtain the 3 peaks when you do the FFT. Same thing जैसे that you are doing the DSB AM, okay, AM signal है ना, बस एक में phase shift आया होगा, ठीक है ना। And in the wide band FM you will obtain a large number of frequency components. Okay, so actually ना FM signal की bandwidth पता है, FM signal की bandwidth infinite होता है। जो भी FM सिग्नल हम देते हैं ना वो असल में वाइड बैंड FM होता है यूटिलाइज, और उसकी बैंडविड्थ इनफाइनाइट होती है। और जो नैरो बैंड FM है ना उसकी बैंडविड्थ कितनी है, वो जो निकाल सकते हैं 2 टाइम्स होगी, ठीक है ना, किसी AM सिग्नल की 2 टाइम्स FM सिग्नल, ठीक है। तो देयर इज नो डिफरेंस बिटवीन अ नैरो बैंड FM एंड वाइड बैंड एंड द AM सिग्नल। सो वी डू नॉट यूटिलाइज नैरो बैंड FM, we do not utilize narrow band FM communication purpose, we only utilize wide band FM, क्योंकि उसी में हमारी कैरेक्टरिस्टिक्स ऑफ FM सिग्नल रिफ्लेक्ट हो जाती है, ठीक है। AM सिग्नल असल में why do we utilize FM signal is that because AM signal में what happened in AM signal there was a problem that we used to transmit all of the our information in the amplitude of the carrier. Now for example noise आ गया, कुछ और आ गया, disturbance आ गई, तो उसकी वजह से amplitude of the carrier used to change, तो फिर वो डिस्टर्बेंस हमारी रिफ्लेक्ट होती है रिसीव्ड सिग्नल में भी. Now if we store it in the frequency, so the very less possibility is that the frequency there will occur a disturbance as it will change the frequency compared to that noise से amplitude change हो जाएगा. It is more usually हम consider करते हैं ना AWGN noise, additive white Gaussian noise, okay? तो उससे usually amplitude ज़्यादा change हो जाता है, ठीक है ना? फ्रीक्वेंसी पे कम असर पड़ता है compared to, तो it is much safer to transmit. ये ऐसी बात है, अगर हम एम्पलीट्यूड मॉड्यूलेटर यू कंसिडर AM सिग्नल एज एफ गाड़ी हम चला रहे हैं, गाड़ी की फ्रंट सीट पे किसी को रखा हुआ है, अगर टक्कर हो गई ना तो जो आदमी फ्रंट सीट पे होगा वो मर जाएगा. अब जो FM सिग्नल है ये बीच वाली सीट पे रखा हुआ है हमने मैसेज को अपनी, ठीक है ना. सो कुछ नहीं होगा, दोनों साइड से भी टक्कर आए कुछ नहीं होगा, ठीक है ना. इट इज़ मच सेफर टू ट्रांसमिट आवर सिग्नल यूजिंग द FM, ओके, फॉर FM. एंड ऑल्सो हमें पावर भी बचता है FM सिग्नल में, ठीक है ना, कंपेयर टू द AM सिग्नल पावर बच जाता है, ठीक है.
FM में कितना पावर होना चाहिए अगर आप अंदाजा लगे? Power is related to actually your amplitude of your signal, right? So अगर हम ideally देखते हैं तो FM का amplitude is gonna be constant, right?
Yes,
AC is going to remain AC. तो आपका average power जो carrier का unmodulated carrier का your power of your modulated signal should be around the average power of the carrier you also, and because amplitude is not changing. So you can measure the power. इसमें power भी measure करते हैं. You can measure average power. करते हैं ना शायद average power.
इसमें पता नहीं, ये लंबा हो जाएगा बहुत.
स्क्वायर पाई.
हाँ, you can do it yourself also.
AC
AC
square by
square.
2
Take R is equal to what? AC square.
और मिस
AC square by 2
average value ले ली.
एक्चुअली ना स्पेक्ट्रम FM में अगर वाइड बैंड हो यही पावर रीडिस्ट्रीब्यूट होता है. नया नहीं.
We are not transferring any more power to the carrier, okay? हम सिर्फ उसकी frequency change कर रहे हैं, ठीक है ना. तो हम amplitude modulator में we use it to change the carrier amplitude. So we are providing it more power, excess power, okay? So now we are saving that power. But अब डिफेक्ट क्या आ गया इसमें, इसकी बैंडविड्थ हो जाती है इनफाइनाइट, मैक्स बहुत ज़्यादा हो जाती है, इनफाइनाइट हो जाती है. नाउ देयर इज अनदर रूल फॉर दैट इन ऑर्डर टू कैलकुलेट द FM बैंडविड्थ, दैट इज द कार्सन रूल, ओके. वो आप आगे पढ़ो, वो आपको ठीक है. सो आप ये सब कैलकुलेट करो, फिर नोटिस करो, ऑब्जर्व द स्पेक्ट्रम पैटर्न फॉर बोथ नैरो बैंड FM एज वेल एज वाइड बैंड.
वाइड बैंड
यहाँ पे इनको अपने
टेबल्स पे करेंगे
है इनको.
हाँ हाँ.
कितना है
FM जल्दी है.